Hello students, very good morning. In this session, we are going to discuss about the topic Ehrenfest Theorem. Ehrenfest Theorem is important in quantum mechanics because it helps establish a connection between the quantum and classical mechanics, allowing us to understand how classical behavior emerges from the quantum systems. This Ehrenfest theorem is a key concept in quantum mechanics that helps us reconcile the behavior of the quantum system with the classical expectations. It is a valuable tool for physicists and educators alike, aiding in the understanding and applications of the quantum theory in a broader context. So let us come to this statement of the Ehrenfest theorem. The Ehrenfest theorem states that the average motion of the wave packet agrees with the motion of the corresponding classical particle. In other words, we can say that the Schrödinger wave equation leads to the satisfaction of classical Newton's laws of motion on the average. Okay, so now one by one we can see the complete derivation for this Ehrenfest theorem. Now you please think about the two equations. The two equations should be derived and should be equation in this session. The first one is C d by dt expectation value of x. That is nothing px by m. And second one is d by dt of expectation value of px, that is nothing expectation value of force. See, these two are nothing, are basic classical Newton's law of motion. Now through this Ehrenfest theorem, we need to apply the quantum mechanical treatment on this, on the basics of the classical Newton's law, and we need to prove this one. First, consider the first proof, means first one, d by dt of expectation value of x. So now let us consider the first one, d by dt of expectation value of x, that is nothing expectation value of px by m. So here x is a position coordinate of a particle of mass m at any time t. So now you think about the only the expectation value of x, which is given by expectation value of x is equivalent to integral over minus infinity to plus infinity psi star of x comma t, then x, then psi of x comma t dx. Consider this is equation number 1. Now you please differentiate this equation. Differentiate the equation number 1 with respect to time t, because we need to get the d by dt of expectation value of x, no? So you differentiate on both sides of the equation number 1 now. So if you differentiate it, what you will get? D by dt of x. That's nothing but integral over minus infinity to plus infinity. And the x is there. This x. You consider dou by dou t psi star psi here into dx. Right. Now you consider this equation as equation number 2. Now we have the equation, expectation value of the x is this one. After that, we differentiated this one with respect to t. So this is what? D by dt of expectation value of x. Now you please consider the probability current density equation. According to the probability current density equation, we can think dou by dou t psi star psi, that is nothing, I h cross by 2m dou by dou x, it's nothing psi star dou psi by dou x minus psi dou psi star by dou x. You consider this is equation number 3. So I have taken now d by dt of expectation value of x. And as per the probability current density equation, actually we derived this equation in the regular session. So now we are going to replace this step dou by dou t of E psi star psi. We are going to replace this step with this probability current density equation. Just apply this equation here, what you will get? D by dt expectation value of x, that is nothing, I h cross by 2m integral over minus infinity to plus infinity x dou by dou x bracket psi star dou psi by dou x minus psi dou psi star by dou x into dx. So after applying the probability current density, we got this one. So now what we need to do here, just simplify this equation by using the integration by parts. Take the integration, integrating this one by parts. We know that equation. No, what is the basic equation? Please consider integral over u dv means uv minus integral over pd. Now here you please consider this x. U is u. Okay. Consider x is a u, and this complete statement becomes what? It is dv. So you please consider dv is equivalent to dou by dou x bracket psi star dou psi by dou x minus psi dou psi star by dou x into dx. So if u is equal to x means, if you want to take du means that is called dx. Like that, if you want to take the v from this way, you need to integrate on both sides. If you integrate it, what you will get? So v is equivalent to psi star dou psi by dou x minus psi dou psi star by dou x only. That's all. Now you please take this equation by using the integration by parts. So if you use it, what you will get? So d by dt expectation value of x is nothing but, and you please keep the same, this one I h cross by 2m, and in this integration by you need to simplify by using this integration by parts. So if you will do like this formula, what you will get? U, that is nothing here, x, and v, that is nothing, this one. So bracketed to psi star dou psi by dou x minus psi dou psi star by dou x, and limit is there, no? So you use minus infinity to plus infinity, and this minus as per this formula you use here, and this constant term also you can utilize one more time, I h cross by 2m, and then integral over minus infinity to plus infinity v du. What is the value of v? Psi star dou psi by dou x minus psi dou psi star by dou x. Du, instead of that du, you can use here dx. That's all. This is just a simple step. Now, in this equation, you please see the first step, this one. This one, if you apply this infinite and minus infinity for the x and psi for any term, that will become 0. So we can write the first term becomes 0 because psi star dou psi by dou x and dou psi star by dou x all will tend to 0 as x tends to plus or minus infinity. Okay, that point. So if the first step becomes 0 means what we will get? Here you will get, so d by dt expectation value of x, that is nothing. So this full becomes 0. So 0 minus this steps only there. I h cross by 2m integral over minus infinity to plus infinity. So psi star dou psi by dou x minus psi dou psi star by dou x int dx. So now again, just a simple mathematical steps only we are doing here. And at the end, finally, we are going to get the proof for the first equation. Okay, continue. Let me continue the simplification for this. So d by dt expectation value of x is nothing but minus. Please think about the simplification on this. Consider 1 by 2m only. And integral over minus infinity to plus infinity. And take the psi star. And you put the minus I h cross inside it. So if you do it, what you will get? Minus I h cross dou by dou x psi and dx. I'm going to split this one, right? And this minus becomes plus. Again, this you need one more time. You should use 1 by 2m here. Then integral over minus infinity to plus infinity. What you will get? So now psi. Here there is no minus. So plus I h cross dou by dou x, then psi star is there, then dx. So now come to the point. So d by dt expectation value of x is nothing but 1 by 2m. What is this? This complete step is nothing but the expectation value of minus I h cross dou by dou x. So we can write the expectation value of minus I h cross dou by dou x plus, here also we can use 1 by 2m expectation value of I h cross dou by dou x. See here you need to think one point here, that minus I h cross dou by dou x means what? It is a momentum operator. It is considered as a momentum operator that we studied already. Hence, this becomes d by dt of expectation value of x is nothing but 1 by 2m. This is what? Px. Plus here also you please consider, what is this? This is a complex conjugate of the previous one. So if you will take the complex conjugate and the expectation value for the complex conjugate, you will get the same result. So again we can write like this. Then nothing. It is simple mathematics. You do. So 1 by 2m, actually 2 times of this one, no? Expectation like this. This 2 will be cancelled. So what you will get? Px, expectation value of Px by m. So finally, we can write d by dt expectation value of x, that is nothing but expectation value of px by m. This is what? This is the first equation, proof of the first equation for the Ehrenfest theorem, right? So it is analogous to the classical particle. I mean classical as per the Newton's law of motion. What result we are getting, the similar result we are going to get for the quantum systems also. Okay. So let me continue for the second one. What is the second equation? Second equation, we need to derive, okay, we need to prove d by dt expectation value of px, that is nothing, force. We know the Newton's second law of motion. What is that? F is equivalent to minus dp by dt. Means force is nothing but it is a rate of change of momentum. Right? Force is nothing but rate of change of momentum. See this equation. What difference between this equation and this one? Both are same. Only thing is here we are applying the expectation value for force. What we are getting? The same d by dt of expectation value of px. Okay, so now through this, we need to once again prove this equation here. Now consider the expectation value of px, that is given by what we are getting. Consider the expectation value of px, that is nothing, integral over minus infinity to plus infinity psi star minus I h cross dou by dou x, then psi dx. That's all. So now small simplification we are going to do on this for getting the proof of the second equation. So expectation value of px is nothing minus I h cross integral over minus infinity to plus infinity psi star dou psi by dou x dx. Consider this equation as a fourth one. Okay. So now we need d by dt of for proving, getting proof of this one. We need to do the differentiation with respect to t for equation 4. Yeah, we need to do. So d by dt expectation value of px, right, that is nothing minus I h cross integral over minus infinity to plus infinity d by dt bracket psi star dou psi by dou x into dx. Again, just a simplification, d by dt of px, expectation value of px is nothing but minus I h cross integral over minus infinity to plus infinity. Now you please differentiate this one inside it. What you will get? Dou psi star by dou t dou psi by dou x plus psi star dou square psi by dou x dou t into dx. Now you please consider this equation as a equation number 5. So here we need to think one point, means we need to get the value, expanded value for the dou x dou psi star by dou t and dou square psi by dou x dou t. For these two, we need to get the value from the time dependent Schrodinger wave equation. You know, according to time dependent Schrodinger equation, Schrodinger wave equation, we can write what is that? I h cross dou psi by dou t, that is nothing minus h cross square by 2m dou square psi by dou x square plus v psi. This is one equation. Consider equation number 6. Now you please take the complex conjugate for this one. So what is your aim now? Now we need to get the value of the dou psi star by dou t one, and the second one dou square psi by dou x dou t. That value we need to find. So now here you see complex conjugate of the above equation. So what you will get? Complex conjugate. Here I know. So minus I such cross dou psi star by dou t equivalent to minus h cross square by 2m dou square psi star by dou square dou x square plus b psi star. Right. Okay. So now we are going to take the, if we can get the value dou psi star by dou t from this. So you please simplify this one further. So what you will get, if you make this small mathematical simplification here, what you will get? So dou psi star by dou t, that is nothing. 1 by minus I h cross bracket this term h square by 2m dou square psi star by dou x square plus b psi star. You consider that this is equation number 7. Now we got the results of this one. Which one? This one. Again we need the one more data, means dou square psi by dou x dou t. We need to get from the same equation. Consider the equation 6 and differentiate. Now differentiate the equation number 6 with respect to x. You will get that value. Right. So if you will differentiate this equation number 6, what you will get? So I h cross differentiation, no, already one differentiation there. Again, if you differentiate, what you will get? Dou square psi by dou x, because we are differentiating this one with respect to x and dou t, right? And here you apply the same minus h cross squared by 2m, and here also what you will get? 3 times. It's already second order differential equation there. So it becomes dou cube psi by dou x cube plus b psi. And for this also, the differentiation you need to use. So dou by dou x v into psi. Right? Again, you simplify this one. Dou square psi by dou x dou t equivalent to 1 by I h cross minus h cross square by 2m dou cube psi by dou x cube plus dou by dou x v psi. Take this one. You consider this equation as a number 8. Now we have two equations. One equation number 7, and next one equation number 8. So take the equation number 7 and 8 and apply the same in the above equation. If you apply it, see here we need this one, no, dou psi star by dou t, we got it now. Then dou square psi by dou x dou t, that also we got. Now we apply the same in equation number 5. What you will get? So take the equation 7 and 8. Okay. Apply the same in equation number 5. So what you will get? So d by dt expectation value of x is equivalent to minus I h cross already there. So take integral minus infinity to plus infinity. Substitute the 7th equation. 1 by I minus I h cross bracket minus h cross squared by 2m dou square psi star by dou x square plus b psi star, then dou psi by dou x, this one. right? So in this part, we take equation number 5, this part we applied and this also there, right? Okay. Plus the next step is also there, plus psi star. In this also, those square, instead of this, you can apply this one also. 1 by I h cross minus h cross square by 2m dou cube psi by dou x cube plus dou by dou x v psi. Right. So finally, and this what we sorry, we will get dx. Right. So now again, just a simple mathematical steps, simplification. Simplification only we are going to do now. See here, d by dt, expectation value of px. See here, minus I h cross. Here you need to get out the minus I h cross from this one and this one. So automatically this step and this steps, and here we put minus here, right? Will be cancelled. So what we will get? So integral over minus infinity to plus infinity minus h cross square by 2m, then dou square psi star by dou x square plus v psi star, that is there, then dou psi by dou x, that will be there. And here, due to the extraction of the minus, here you need to put minus. Then remaining steps, psi star minus h cross square by 2m dou cube psi by dou x cube plus dou by dou x v psi into dx. Again, simplification is just a mathematical simplification. If you concentrate it, you will get this answer. If you simplify, I am going to split this one integral. Integral over minus infinity to plus infinity minus h cross square by 2m dou square psi star by dou x square plus v psi star, then dou psi by dou x into dx minus integral over minus infinity to plus infinity and this psi star minus h cross square by 2m dou cube psi by dou x cube plus dou by dou x v psi into dx. You consider that this is equation number 9. So again, further simplification, you just make the further simplification on this to know, split it. So d by dt expectation value of px equivalent to integral over minus infinity to plus infinity minus h cross square by 2m bracket dou square psi by dou x square and multiply it with the inside dou psi by dou x and dx plus, if you split it, what you will get, integral of minus infinity to plus infinity and v psi star dou psi by dou x into dx minus this step, split it, integral over minus infinity to plus infinity psi star bracket minus h cross squared by 2m, then dou cube psi by dou x cube bracket into dx. Oh, sorry, not minus, because this minus becomes minus here. Then integral of minus infinity to plus infinity. This psi star dou by dou x v into psi into dx. Here you see, just to take the simplification again, and this step almost similar, no? I mean, minus h cross by 2m is there. So take a common term. So d by dt, expectation value of px, integral over minus infinity to plus infinity. Take a common term, minus h cross square by 2m. Consider this one, first one and the third one. It is a common, then bracket dou square psi by dou x square, dou psi by dou x, and this step minus psi star dou cube psi by dou x cube into dx. So I made a simplification for making like this. Then, and this steps plus integral over minus infinity to plus infinity. Take these two one. V psi star dou psi by dou x minus these steps psi star dou by dou x v into psi into dx. Here, what I am going to do here, and again we need to make the one small simplification on this. So d by dt, expectation value of px, that is nothing. You please carefully watch this one. Integral over minus infinity to plus infinity. Here I am going to take the minus h cross square by 2m on the outside. So take minus h cross square by 2m outside. Integral over minus infinity to plus infinity. Now consider the dou by dou x is a common term from this. So bracket, what you will get? Dou psi by dou x, right? Then actually now we forgot about one small thing on this. You please see what is the value. From this we need to think about this star. We forgot, you consider, right? Okay, see, small correction on this you need to make. And here what you will get? Dou psi star, no? Okay, then dou psi by dou x minus psi star dou square psi by dou x square into dx. Okay, got it. Plus integral over minus infinity to plus infinity, right? V psi star dou psi by dou x minus psi star, and we will expand it later in the next equation. Dou by dou x into v psi, the whole thing, and dx. Now here in this equation, you please consider this integration and the differentiator. And finally, this becomes what? Will be cancelled. So this equation, if we simplify it, how it will be there? So you can see d by dt, expectation value of px, that is nothing but minus h cross square by 2m here, and this will be cancelled, and remaining terms dou psi by dou x. I'm sorry, dou psi star by dou x into dou psi by dou x minus psi star dou square psi by dou x square, but limit is there. So minus infinity to plus infinity. And plus see this equation, expand it. If we expand it, minus infinity, integral over minus infinity to plus infinity, v psi star dou psi by dou x minus, keep this psi star, and please think about this one. If you differentiate this one, dou by dou x, v psi, no? So differentiate. You keep the v is a constant now, then dou psi by dou x, then minus again psi star. Now psi is a constant, no? So dou v by dou x. And finally, and here we can put dx. And here you see, and v psi star dou psi by dou x. Here minus v psi star dou psi by dou x. So both are plus minus, no? So you can cancel. And finally, what you will have in this. And here also you see, if you substitute the infinity and minus infinity on this equation, and this becomes again what? 0. So hence, this equation becomes d by dt expectation value of px. It is nothing. The first term completely becomes 0 plus, and here the remaining steps, integral over minus infinity to plus infinity, and this minus there, no? So minus psi star, you can take like this, psi dou v by dou x into dx. So we can make this equation like minus integral over minus infinity to plus infinity, psi star, or don't take minus, you can put minus inside. Okay, take integral over minus infinity to plus infinity, psi star minus dou v by dou x psi dx. So here you see, so d by dt integral over, I mean expectation value of px is nothing but integral over minus infinity to plus infinity, psi star bracket minus dou v by dou x psi dx. This is nothing, expectation value of minus dou v by dou x. Minus dou v by dou x means what? It is a force, it's a potential we studied. Minus dou v by dou x, which becomes what? It is a force, right? Hence, this equation proved now. So d by dt expectation value of px, that is nothing, expectation value of force. Hence, as per the Newton's second law, we are getting the similar results in the quantum mechanics, like d by dt expectation value of px is equivalent to expectation value of fx. Hence, we proved the both equation. This is equation number second Ehrenfest theorem, right? So the summarization as per the Ehrenfest theorem, first Ehrenfest theorem. So what we derive in the first Ehrenfest theorem. So in the first Ehrenfest theorem, we derive and prove the d by dt expectation value of x, that is nothing, expectation value of px by m. As per the second Ehrenfest theorem, I mean what we derive, what proof we got, d by dt of expectation value of momentum px equivalent to expectation value of force. So hence proof. Okay, students, thank you. So we will meet the next session. Thank you so much.